Okay, welcome back to the channel. So we've got another video on partial fractions. Now you would have seen these two sums already. We've done these two before. But now what we're going to do is do it via a different method. So last time we used substitution. So we trialed out different values of x to get rid of a and b. But now we're going to do something else. So the first step though remains exactly the same. What we need to do is change this and change this. Make sure they have common denominators, i.e. the ones on that side. So we'll keep this one the same. You've got 4 plus x, and then 1 plus x, 2 minus x. Now that needs to be exactly the same as a, and on the bottom here, it's already got a 1 plus x. We need it to have a 2 minus x, so then times the top by that as well. And the same over here. This already has a 2 minus x. So what we need to do, multiply it by 1 plus x. And there we go. So we've got our two fractions now. Denominators is exactly the same as it is on that side. And so what we do is just get rid of the bottoms and we can focus just on the tops. So you've got 4 plus x should be exactly the same as a times by 2 minus x and b times by 1 plus x. But now what we're going to do is this. We're going to multiply out this side. So we'll keep this as 4 plus x and now times this out. So a times 2, that's 2a. Then a times by negative x, we'll say minus ax. Then we've got b times 1, that's just b. And then we've got b times by x, so plus bx. Now, where do we go from here? So you can see at the moment, we've just got an x on the left-hand side. And what I'm going to do is I'm going to put a 1 in front of it because it's just 1x. On this side, we've got two terms that have an x in them. So we've got minus ax and plus bx. So what we can say is that these two terms must be the same as the x term. So what we can say is 1x must be the same as minus ax plus bx. And then because every term has an x, well, we can just get rid of those. So it was the same as just saying minus a plus b is equal to 1. And that's why this method is called comparing coefficients. So we're comparing the numbers in front of the x's there. So we've got that is equal to minus a plus b. Now what we can do is exactly the same thing but with the 4. So 4 is just an ordinary number, it's a constant. And so 2a and this plus b must be equivalent to that 4 because these as well are just constants. They don't have any x's attached to them. So we can say 2a plus b should be equal to 4. And now what you can see is you've got two equations here that you can solve simultaneously to give you what a and b are. So I'm just going to take this and write it underneath this one. So we'll have minus a plus b equals 1. And I'm going to subtract these two equations. So 2a minus a, that's going to give me 3a. b minus b is nothing, so that's gone, is equal to 4 minus 1 is 3. And so we can tell that a is just equal to 1. Sub it back in if you want into any of these and we'll get what b is. So let's take it and plug it into here. Well, I should just do it here actually. So that's just minus 1 plus b equals 1. And so we know b is equal to 2. And there we go. So we know a is 1 and b is 2. And so just to write that all out nice and neatly, that's 1 over 1 plus x plus 2 over 2 minus x. And there we go. So completely different method there, but we do get to exactly the same answer. Now, let's check out this one over here. So first step is exactly the same. So start out by making my denominators the same. So I'll have a x minus 3 and, that's supposed to be 3x minus 1. Okay, there we go. And so the top there we need to multiply by 3x minus 1. And then plus b, which only had a 3x minus 1, but now we need to have x minus 3 as well. There we go. So now because the denominators are the same, we'll just get rid of those and focus on the tops. So 3x minus 1 plus b over, no, sorry, b times by x minus 3. So what we'll do now, expand everything on the right hand side. So 8 should be the same as 3ax minus a plus bx and minus 3b. So again, let me just ring the x terms here. We've got 3ax and then plus bx. But on this side, there's no x's. So this is the same as saying, well, 0x. And so let's take the x terms on the left, x terms on the right, set them equal to each other. So you've got 0x is equal to 3ax plus bx. Remember, they've all got an x, so we can say it's just 3a plus b. And there we go. Now, let's do the same with the constants or the numbers. So you've got 8 on this side. Let's write that over here. 8 is equal to minus a minus 3b. Okay, there we go. So we've now come up with two equations again that we've got to solve simultaneously to find out what a and b actually are. So what can we do? Oh, well, I'm going to rearrange this one. I'm going to say this is minus b is equal to 3a, because I can take that across to the other side. And then, oh, actually what we can then say is b is equal to minus 3a. And I'm going to take that and substitute it into there. So I've got 8 is equal to, this will be minus a minus 3 lots of minus 3a. So 8 is equal to minus a plus 9a. And so 8 is equal to, well, 8a. And so a is equal to just 1 over there. Now take it and we'll substitute it back into one of these. Let's sub it into this over here. Or in fact, we can just sub it right here. b is equal to minus 3 lots of 1. And so b is just equal to minus 3. There we go. So very easy. There we go. We've worked out a is 1 and b is minus 3. And if you wanted to write that out neatly, let me just do it over here. We'll have that as 1 over x minus 3. Take away 3 over 3x minus 1. And that's that.